In this video, we will solve the equation 9 to the nth power minus 15 to the nth power minus 25 to the nth power equals 0. If we analyze these bases, then we see that 9 is 3 times 3, 15 is 3 times 5, and 25 is 5 times 5. So 9 and 25 are perfect squares, and 15 is 3 times 5. To solve for n, we will start by dividing both sides either by 9 to the nth power or by 25 to the nth power. I will start by dividing both sides by 25 to the nth power. So here we have it, and now on the left side I will use the power of a quotient formula. In this formula, if in the numerator we have a raised to an exponent n, and in the denominator we have b raised to the same exponent n, then we can write this as a over b all raised to exponent n. Then according to this formula, I can write the first fraction as 9 over 25 all to the nth power. The second fraction will be 15 over 25 all to the nth power. Then the third fraction becomes minus 1, and on the right side we will have 0. And now, because 9 is 3 squared and 25 is 5 squared, we will rewrite this fraction as 3 over 5 to the power of 2n. So we will have 3 over 5 all to the power of 2n minus, and now if we reduce 15 over 25, we will have 3 over 5 to the nth power minus 1 equals 0. And now notice that both these terms have the same base. So if we will use a substitution, we can convert this equation into a quadratic equation. Let the expression 3 over 5 to the nth power be equal to a number x. Then if we do this substitution, we will get x squared minus x minus 1 equals 0. So as you see, because I had these special numbers in the beginning, I was able to create the same base and then convert this equation into a quadratic equation. And now to solve this equation, factoring will not work. Therefore, we need to use quadratic formula. If we have a quadratic equation of the form ax squared plus bx plus c equals 0, then we can find the solutions using this formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a. So in this formula, we need to use the numbers a, b, and c. In our equation, a is 1, b is negative 1, and c is also negative 1. Then x equals, and now we have to start with negative b. If b is negative 1, then negative b will be positive 1 plus or minus square root of negative 1 squared minus 4 times 1 times negative 1. All this over 2 times 1. Inside the square root, negative 1 squared is 1, and negative 4 times negative 1 is positive 4. Then 1 plus 4 will make 5. And now x equals 1 plus or minus square root of 5 over 2. So this equation has two solutions. One is 1 plus square root of 5 over 2, and the other one is 1 minus square root of 5 over 2. So we have x, but now we have to find n, which will be the solution to the initial equation. Here we have the relation between n and x, and that is 3 over 5 to the nth power equals x. This equation tells us that if we have a positive base and we raise it to any exponent, the result will always be positive. So if we want to replace this x with the solution that we got here, then we need to use only the positive one, and that is 1 plus square root of 5 over 2. So then we will have 3 over 5 to the nth power equals 1 plus square root of 5 over 2. You might recognize this quantity as the golden ratio. And now, because this is an exponential equation, to solve for n, we will use logarithms. We can take the logarithm on both sides, and we can use any base we want. For example, we can use the base 3 over 5, then on the left side, we will just have n. However, I will use the natural logarithm, and that is because if I want to round the answer, then it will be easier to type the expression on the calculator that I usually use. So then, on the left side we will have a natural logarithm of 3 over 5 to the nth power equals natural logarithm of 1 plus square root of 5 over 2. Now to solve for n, we need to use the power rule for logarithms. The power rule is log base b of x raised to exponent c equals c times log base b of x. So this rule allows us to take the exponent c and move it in front of the logarithm. So in our equation, we will take the exponent n and we will move it in front of the logarithm. Now we will have n times natural logarithm of 3 over 5 equals natural logarithm of 1 plus square root of 5 over 2. To solve for n, we need to divide both sides by natural logarithm of 3 over 5. Then on the left side, natural logarithm of 3 over 5 will cancel, and n will be equal to natural logarithm of 1 plus square root of 5 over 2 all over natural logarithm of 3 over 5. And this is the exact solution to the original equation. But if we want to get an approximate solution, then we can use the calculator. Then if we use the calculator and if we round, then we will get that n is approximately negative 0.94. So now we have the approximate solution. I hope you liked this problem, and if you came up with any other method of solving it, please leave a comment, and thank you for watching.